Hey guys, welcome to my video on writing equations of parallel and perpendicular lines. Okay, so we left off having to talk about how to write lines using slope-intercept form and using point-slope form. So in this video, I'm going to show you how to use each form in writing equations of parallel and perpendicular lines. Okay, so let's review. So there are three types of lines. Technically, there are four, but three is what we're going to focus on. So intersecting lines are if the first line and the second line intersect if the slopes are not the same. Okay. Parallel lines, the lines are parallel if the slopes are the same. And then perpendicular lines that meet exactly at 90 degrees, the slopes have to be, when you multiply them, they equal -1. Or the slopes have to be opposite and reciprocal. Okay, so let's begin. So let's say it's asking us which equation is of a line passes through 6 comma -2 and is parallel to y equals 2x minus 3. Okay, so we have a point here and we have an equation here. In order for you to write the equation of the line that's parallel to it, you have to have the same slope. So first find out what the slope is in this equation. So because this is in slope-intercept form, the slope here is mx plus b. So m here is 2. This means that when we're writing the equation, we must use 2 as my slope. Now it has to pass through this point. Okay, so this is a point on the line. So if you remember, if you have a point and a slope, you can use the point-slope form. So we know this is x1 is equal to 6, and we know y1 is equal to -2. Because we have a point and we have a slope, we're going to use the point-slope formula first. I'm going to substitute in what I know. And my slope is 2. Then I'm going to solve for this y so that, and I'm going to distribute 2 with x and 2 with -6 already. Then I'm going to subtract 2 from both sides. So that gives me y equals 2x minus 14. So 2x minus 14 is my equation. That's going to be parallel to 2x minus 3. And it'll pass through the point 6 comma -2. How do we know? Let's test it out. In order for this line and this line to be parallel, they have to have the same slope. And as you can see, the slope here is 2 and the slope here is 2. In order for this equation to pass through 6 comma -2, you have to plug in a 6 to this x, and you have to plug in a -2 to this y in order for this to be, and then test to see if they are equal. So this is just a check again. So 2 times 6 minus 14. All right, and then the right side should equal -2. And that is true because 2 times 6 is 12, minus 14 is equal to -2. So now we know that they have the same slope, which are parallel, and it passes through 6 comma -2. So D is the right answer. Okay. Let's take a look at this equation. It says, what is the equation that's parallel to y equals -x minus 22? Okay, so first and foremost, we want to know which one of these equations are going to be parallel, meaning they have to have the same slope. The first thing you have to notice is that this is in slope-intercept form, but this is in this is in standard form. Okay, so standard form is different. Standard form is ax plus by equals c, where c is by itself. Okay, this is y by itself. Okay, so in order for it to be parallel, you first need to identify if they have the same slopes. So what I could do here is I could change all of these into slope-intercept form and compare it with this line right here. All right, so we have here -y is equal to, I'm going to move this x over to the other side, so that's -x plus 22. Actually, it's probably easier if I move the y to the other side. So let's do y on the other side. So I'm going to move this y and then this 22. So this becomes y equals x minus 22. Okay. Now if we compare, we notice that they're not parallel because they don't have the same slope. So A can't be the answer. All right, so here I'm going to move this x over to the other side. So that's y equals positive x positive 22. And again, these two are not parallel because they don't have the same slope. All right, now here, y equals, I'm going to move this positive x over to the other side. So that's -x minus 17. So right now, this looks like they're parallel because they have the same slope and they have the same slope and different y-intercept. But let's check letter D. So 2y is equal to x. So plus x equals -22. I'm going to move the x over to the other side. So I still have a 2y, and now I have a -x minus 22. And when you divide by 2, because you want y by itself, you don't get the same slope. You have negative 1/2 x minus 11. So therefore, C is the right answer. So parallel lines always, always, always have to have the same slope and different y-intercept. Okay? Okay, so let's take a look at perpendicular lines now. So it says, what is the equation of a line that passes through 9, 3 and is perpendicular to the line given by the equation 4x minus 5y equals 20? Okay, so there's a couple of problems that I see here. Number one, the forms are all different. So this is a standard form, and then the forms that they give you are in point slope form. So first, what we need to do is make the standard form into slope intercept form. So we have 4x minus 5y is equal to 20. It's probably easier for you to move the negative 5y over to the other side and a 20 over to this side. So what that gives me is 4x minus 20 equals 5y. Okay. Now we're going to divide each term by 5 to get y by itself. So now we have y by itself is equal to 4/5 x minus 20 divided by 5 is 4. Okay, so this is the line that's equivalent to 4x minus 5y equals 20, just in different forms. Okay, so this is where we want to focus in. Okay, so now it says, what is the equation of a line that passes through 9, 3 and is perpendicular to this line? So we know perpendicular lines, they have to have the opposite reciprocal slopes. So right now our slope is 4/5. So the slope that has to be perpendicular, it has to be its opposite and reciprocal, which is equivalent to negative 5/4. Okay. And now if you want it to pass through 9, 3, that means x sub 1 is equal to 9, and then y sub 1 is equal to 3. And at this point, because I'm given a point and a slope, I'm going to use the point slope form. So I'm going to just write down what I know and substitute y sub 1 equals 3. M now is negative 5/4, right, because it needs to be perpendicular. And now this is x equals x minus 9. So these are all in point slope form, and all I have to do now is match it. And it looks like the answer here is letter A. Okay, so that's how you write a line that's perpendicular. Okay. All right, and let's try another perpendicular one. So it says, what is an equation of a line that contains the point negative 4, 1 and is perpendicular to the line given by y equals negative 2x minus 3? So right now this is in slope-intercept form, so it's easier for us to leave it as slope-intercept form and identify the slope. So the slope now is negative 2. The slope that has to be perpendicular to this line has to be its opposite and reciprocal. So its opposite and reciprocal becomes 1/2. Okay. Now they want us to write a line that is going to cross this point. So which means my x sub 1 is equal to negative 4 and my y sub 1 is equal to positive 1. Now that I have a point and a slope, all I have to do is write it in point slope form first and substitute what I know. X minus 4 is x plus 4, so that's what I'm going to write down here. Okay, now I'm going to distribute 1/2, so that becomes 1/2 x plus 2. And I'm going to add 1 to both sides, right? All right, so that's y equals 1/2 x plus 2 plus the 1 that I'm adding. So altogether, I have y equals 1/2 x plus 3 in slope-intercept form. So which is choice letter B. Okay, let's take a look at another example. All right. It says these two lines are represented by the given equations. What would be the best statement to describe these two lines? Okay, so 2x plus 5y equals 15 is in standard form, and this is some sort of a form that's neither standard slope-intercept or point slope. So let's choose one form so that we can quickly identify. Where we can quickly identify the slope is the point slope form or the slope-intercept form. And right now, it's easier for us to leave it at slope-intercept form, y equals mx plus b. So to do this, I'm going to subtract the 2x over to this side. So I have 5y equals negative 2x plus 15. Then I'm going to divide by 5 so that I know what the slope is. So this equation is going to be y equals negative 2/5x plus 3. Okay. So I know the slope is negative 2/5. Now the other one. Now this one. So this is going to yield I'm going to use a distributive property to distribute 5 to x plus 1. So that becomes 5x plus 5. And now what I want to do is I want to get y by itself. So to get y by itself, I have to get rid of this 20 and bring it over to the other side by subtraction. So that gives me 5x minus 15 equals negative 2y. Then I'm going to divide by negative 2 to all the terms here. So I have y equals negative 5 over 2x plus 15 over 2. Okay. So I have two lines that I need to compare. Y equals negative 2 over 5x plus 3. And y equals negative 5 over 2x plus 15 over 2. We must compare the slope to see if they're the same, opposite reciprocal, or if they're just two different slopes. So we have here negative 5 over 2 and negative 2 over 5. So we know they're not parallel because they're not the same. So that marks out letter A. We know that these two lines are not the same line because they don't have the same exact slope and same exact y-intercept. We know these lines are not perpendicular because although this is a reciprocal, it's not its opposite sign. So that must mean these two lines are intersecting because the slopes are just not equal to each other. So this is letter D. All right, and that's it. Thank you for watching.